Okay, so for example 5, it says which plane's altitude shows the greater rate of change over the interval of 10 less than or equal to t less than or equal to 15. So let's focus on the words rate of change. Okay, rate of change of altitude. All right, so they're talking about altitude of these planes, the height the plane is. All right, rate of change in general is equal to the change in something, in this case altitude, over change in time. Anytime they ask for a rate of change, that's what we're looking for. Okay, so rate of change of weight, change in weight over change in time. Rate of change of money, change in amount of money over change in time. So that's what rate of change represents typically. So we have two different planes here. One plane we're given a function. Second plane we're given a graph. And we got information that tells us what we need to know in order to figure out the rate of change for the time interval from 10 to 15. Okay, if you look at the time interval, it's about the letter t. So they're telling me what t equals, and t is time, so they're basically giving me information from the bottom here. So if we look at plane A, t is time in minutes after takeoff, A is altitude in feet. So they give me an equation here telling me that A equals 9,200 natural log of t plus 10,000. That's my equation. So if I know that t is equal to 10 and t is equal to 15, because that's what they told me right here, to figure out what A equals, I'm going to replace t in the function to figure out A. So I'm going to type in 9,200 natural log of 10, end parentheses, plus 10,000. So again, I'm just using this function. T is equal to 10, put t right there in the formula, hit equals, and it spits out 31,183.78286. Let's just go nearest whole number, dealing with altitude here. So let's say that's 31,184 feet. Okay. And I want to evaluate that again at t equals 15. So again, I just type in the same formula, 9,200 natural log of 15, end parentheses, plus 10,000. And I'm just using this formula here to evaluate. So I get 34,914 feet. So with that information figured out for this problem, if I want the rate of change of plane A, it's going to be the change in altitude, which is 34,194 minus 31,184, over change in time, which is going to be 15 minus 10. I took the second number minus the first number for change in altitude, so second number minus first number for change in time. Make sure the order of subtraction matches top and bottom. It doesn't matter what order you go with, just don't make it different. So I went bottom minus top, I went bottom minus top. If I did top minus bottom, I do top minus bottom. Okay. 34,194 minus 31,184 is 3,010, I believe. Let me just do that on the calculator to verify. 34,194 minus 31,184. Yeah, 3,010. 15 minus 10, of course, is 5. So if I divide 3,010 by 5, I believe it's 602. Divided by
25, yep, 602.
I think you wrote some
Yeah.
down wrong.
What did I write down wrong?
The second altitude, you're at, it's
Yeah.
914.
Yeah.
9, oh, dang it, 914, thank you. Thought those were pretty friendly numbers, to come out that close.
And that should be.
914, so let's get the right. 34,914 minus 31,184 is 3,730. Divide that by 5, we get 746. Divided by 5, yep, 746, okay. Now, what unit is in the numerator of this fraction? The altitudes are in what unit?
Feet.
Feet, and the time is in what unit?
Minutes.
Minutes, right? T is time in minutes. So if I'm doing a rate of change here, feet over minutes, so that's going to be 746 feet per minute. Typically, your rate of change for this type of problem is going to be a speed. So if you're in this plane, your altitude is increasing by 746 feet every minute over that part of the flight. Okay, as you can see from this picture, it's not a straight line, so it's rapid, then it starts slowing down, but the average rate of change is the 746 feet per minute. In that 5-minute span, you raised up 3,730 feet, so you averaged 746 feet per minute. The second plane, they don't give us a formula like they did here, but they gave us ordered pairs. So basically, they've given us what we have in this chart here. We know where we were at 10 minutes and where we were at 15 minutes. So for this plane B, the rate of change is going to equal the change in altitude divided by the change in time. So, second altitude minus first altitude, 39,449, minus first altitude, 37,497, over second time, 15, minus first time, 10. 39,449, 37,497, no, everything's right. Okay. So again, I'm looking at plane B. These are the stats for plane B. Again, I have ordered pairs. I used the equation to get the ordered pairs on this one because I didn't have ordered pairs. The graph gives me ordered pairs on this one, so I can use that. So the rate of change is going to equal 39,449 minus 37,497. Comes out to 1,952 divided by 5. And 1952 divided by 5 is 390.4. Feet per minute. Okay, so it says which plane's altitude shows the greater rate of change over the interval. The greater rate of change, of course, is plane A. 746 is bigger than 390. It's climbing more rapidly, basically, is what's happening. So, which one? We're going to say plane A. The answer is plane A. The work is necessary to determine that answer. So I would expect in a problem like this, show all the work necessary to determine what they're asking you to find. Right, but again, rate of change, anytime they ask for rate of change, that's how you do it. How much did Y change over how much did X change in your ordered pair structure? Get correct units on whatever rate of change you're dealing with based on the units of what these things, altitude, feet, time, minutes, feet per minute.